Alright, so in this problem, I have x to the power of 3 minus x squared is equal to 4. So to solve this, I'm going to first start by subtracting 4 on both sides. So now I get x to the power of 3 minus x squared minus 4 is equal to 0. Now to actually find all of the solutions for this equation, we need to first start by finding one and use that one solution to find the rest. So to do that, to find the first solution, we need to just start by plugging in numbers. So if I plug in x equals 1, I get 1 minus 1 minus 4, and this does not equal 0, so this is wrong. Now if I plug in x equals 2, I get 8 minus 4 minus 4, and this does equal 0. So x equals 2 is a solution. Now using x equals 2, I'm going to divide x to the power of 3 minus x squared minus 4 with x minus 2. So now if you divide these two, you get x minus 2 times x squared plus x plus 2. And you can either divide them with long division or synthetic division. So now this gives me two equations. I have x minus 2 is equal to 0, and I have x squared plus x plus 2 is equal to 0. So for x minus 2 equals 0, this is simple. This obviously means x equals 2. And for x squared plus x plus 2 equals 0, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 1, and then c is 2. So I get x is equal to negative 1 plus or minus the square root of 1 squared, which is simply 1 minus 4 times a, which is 1 times c, which is 2, all over 2a. And this is equal to negative 1 plus or minus the square root of 1 minus 8, which is negative 7, all over 2. And this is actually equal to negative 1 plus or minus the square root of 7 times the square root of negative 1 over 2. And if you guys already didn't know, the square root of negative 1, this is actually equal to the imaginary number I. So I can actually go ahead and replace the square root of negative 1 with I. So now I get x is equal to negative 1 plus or minus the square root of 7i over 2. So my solutions are x equals 2, x equals negative 1 plus the square root of 7i over 2, and x is equal to negative 1 minus the square root of 7i over 2. Alright, so in this problem, I have x to the power of x to the power of 6 is equal to 144. So to solve this, I obviously want to find the value of x. So I'm going to take the power of 6 on both sides. So I have x to the power of 6, x to the power of 6 to the power of 6 is equal to 144 to the power of 6. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So x to the power of x to the power of 6 to the power of 6, I can switch the places of x to the power of 6 and 6. So I get x to the power of 6 to the power of x to the power of 6 is equal to 144 to the power of 6. Now I'm going to let x to the power of 6 equal to the variable y. So I have y to the power of y is equal to 144 to the power of 6. And I'm going to rewrite 144 as 12 squared. Now, if I have something in the form a to the power of m to the power of n, this is also equal to a to the power of m times n. So 12 to the power of 2 to the power of 6, that's going to equal 12 to the power of 2 times 6, which is 12 to the power of 12. And if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b. So in this case, y is equal to 12. Now remember how we let x to the power of 6 equal to y. So now I have x to the power of 6 equal to 12, and if I take the 6th root on both sides, I get x is equal to 6th root of 12. Alright, so in this problem, I have 2 to the power of x is equal to 1/4 to the power of x squared. And I want to find the value of x here. So, for my solution, I'm going to first start by rewriting my equation. So I have 2 to the power of x is equal to 1/4 to the power of x squared. And now I'm going to first start by rewriting 4 here as 2 squared. So now I have 2 to the power of x is equal to 1/2 squared to the power of x squared. And if I have something in the form 1/a to the power of m, this is the same thing as a to the power of negative m, meaning 1/2 squared, that's simply going to equal 2 to the power of negative 2. And I have this to the power of x squared. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of negative 2 to the power of x squared, that's going to equal 2 to the power of negative 2 times x squared. And negative 2 times x squared, that's negative 2x squared. So now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, I have a to the power of m, I have 2 to the power of x is equal to 2 to the power of negative 2x squared. Notice how x and negative 2x squared, they're going to equal each other because both of these have the same basis. So I have x is equal to negative 2x squared. And to solve this, I'm actually going to divide both sides by x. So I get, these two cancel out, so I get 1 is equal to negative 2 times x. And now we have a simple equation. All I have to do is divide both sides by negative 2 because we want to isolate x. And I'm left with x is equal to negative 1/2. So this is my answer to this problem.